I hope you did all the examples I asked you to do from the first worksheet, that you revised well basic exponential equations from the Form 4 work, and now you're ready to revise the graphs of exponential functions and then what leads us to the inverse of exponential functions. So first we're going to look at the basic function, and we want to analyze a function f of x. And because we will be dealing a lot with the functions 2 to the x or half to the x, let's then take the function f of x defined as 2 to the x as our first function. Now, what do we know about this function? Since the base is bigger than 1, we are looking at a positive base bigger than 1, which means that it is going to be exponential increasing function with the y-intercept of 1. Okay, so if I want to sketch the basic graph, I will have an increasing exponent 2 to the x with a y-cut of 1, and that's everything that I need to sketch about this function. There's no shift left and right, so that's it. If my function, however, is defined as 2 to minus x, I will have a problem. And I always want you to think about exponential function with a negative power, because the definition of exponential function is a to the power of x, not a to the minus x. So if you have minus x, always change it into a positive value, which means that my function g of x is in fact half to the power of x. Not a base 2, but base half, which means that I'm looking at a decreasing exponential function, which has also a y-cut of 1. Okay, sorry, it's moving. So it's a y-cut 1, like the previous one, but it is now a decreasing exponential function. What does two functions have in common? Well, if you look at the domain as the values of x for which the function makes sense is x element of real numbers. Or you can represent this also as x element of minus infinity to plus infinity. It doesn't matter. Okay, but as we can see at the x values, for every value of x, there will be a one value of y. So we are looking at 1-to-1 function. The range is always defined as the y values for which the function makes sense. And in this example, we see that the range is the y bigger than 0. Okay, it cannot be equal to, because x-axis with its equation y equals to 0 does not form a part of the range of exponential function. Now, if I have an exponential function that I shift up or down, so I'm looking at a new function which is defined as 2x shifted up, then the asymptote shifts 2 units up. Now I will have an asymptote at y equals to 2. My function still remains an increasing exponential function. However, the y-cut that I need to calculate by making x equal to 0, in this case the y-cut is, I hope you all said 3, because 2 to the 0 is 1, plus 2, we get a 3. Very often, and we have that in the exams, we see that our function is actually given to us as minus 2 to the x plus 2. Right? And that is when you have to think about what's happening to this function. What's the base of this function? The base of this function remains 2. This minus is just the coefficient. So I have b a to the x plus q. In this case, the coefficient of my base is -1, but my base remains 2 and the power is attached to the base only. What do I know about this function? Well, we're not going to do the entire revision of the Form 4 work. If you need that, you have to go back to your Form 4 textbooks with the exponential graphs. But we know that plus 2, our asymptote remains y equals 2. 2. I need to find now whether this function will have x-cut or not. So the question is, can you calculate the x-cut of this function? How do we calculate the x-cut? We make y equal to 0. And in this case, minus 2x is equal to minus 2. So 2x is 2 and x is 1. I have an x-cut of 1. I hope you remember from our last year's discussion that this minus in front of your exponential function actually indicates a reflection in the x-axis where y becomes a negative y. So I'm looking at a function that is in fact a decreasing function with an x-cut of 1, and I will need to find its y-cut. How can I determine, or how can you find the y-cut of this function? Well, in order to find the y-cut, I need to make x 0. So if I make the x 0, I've got minus 2 to the power of 0 plus 2. 2 to the 0 is 1. So I've got minus 1 plus 2, and my y-cut is 1. Please pause it. I did go fast through it, but that is a basic Form 4 work, so I hope that you don't have a problem with it. Basic exponential equations with the Form 4 work and the exponential graphs with only shift up or shift down. Okay, so we've chosen a function y equals to minus 2 to the x plus 2. We said that this function has an x-cut. So I looked for the x-intercept by making y 0. And therefore, we got the x-intercept as 1. Okay, so if I now want to find the y-intercept, I will have to make x equal to 0. So I have y equals to minus 2 to the 0 plus 2. But 2 to the 0 is 1, and minus 1 plus 2 give me positive 1.